Welcome to this tutorial about finding the area of a triangle using trigonometry. So let's get started. If I had a triangle that looks something like this, how would I find its area using trigonometry? So the first step would be to label this triangle. So let's start by labeling its vertices. So I'm going to say A, B, C. And the important thing to know and understand is that if I have a side labeled A, if I have an angle labeled A, then my side opposite that angle should be labeled with the same letter. What I mean by that is, since this is the angle A, the side opposite that should also be side A. Since this is the angle B, the side opposite should also be side B. Since this is angle C, the side opposite should be side C. So I think you get the point. We should have the angle and its opposite side labeled with the same letter. We know that the area of any triangle, well, hopefully we know this, that the area of any triangle equals 1/2 times the base length times the height, right? And this is something which we've been dealing with quite a lot. How would we transform this into a trig equation? Well, it's quite the same, but to solve this, we need to know what the height is, and that's something we don't have here. So the height of this triangle would be over here. Now I'm just going to label that h since we don't know what the height is. But if I do divide this triangle into two different triangles, then we get a right angle here and a right angle here. So if I label this point here D, then triangle ACD becomes a right angle triangle, and triangle ADB becomes another right angle triangle. With this, if I wanted to find what the sine of angle C was, then, well, using SOHCAHTOA, we know that sine is opposite over hypotenuse. The opposite side to C is the height, and the hypotenuse is B. So sine C would be opposite over hypotenuse. Now if I wanted to find just the height, then I could multiply both sides by B. And if I did that, the b's on this side would cancel out, and I'm left with B sine C to equal my height. And now that I know what the height is, I could just plug that back into the equation here. So the area of a triangle equals 1/2, and the base here is A, so times A, and our height is B sine C times B sine C. So this is the formula for the area of a triangle using trigonometry. So let's go ahead and do a few examples. But before that, let's look at something interesting. What if I was to find the area of a right angle triangle? What would I do then? Well, again, the first thing to do is to label this triangle. So I go A, B, C. Side opposite A, angle A is A, opposite angle B is B, opposite angle C is C. You might be wondering if we'd still be able to use our newly found formula. The answer is yes. So going back here, let's take a look at the formula. It's 1/2 A, which is the base, times B sine C. You could use the exact same formula here, so the area would be equal to 1/2 A B sine C. Here we have A, we have B. Well, we don't really know what the values are, so I'm just going to put this here. But the one thing we know is that angle C is 90 degrees. So if I were to substitute that in, this would just be sine of 90. And the sine of 90 actually just equals 1. So instead of sine c, I'm just going to be substituting 1. And because we're just multiplying this whole thing by 1, we don't really have to consider that. And when we look at the formula now, it's increasingly familiar. So we have 1/2 AB, and going back here, A is the base, so we have 1/2 times the base, and B is the height. So we got back our original formula, which is 1/2 times base times height. And this is the formula which we've been using since, no, elementary school, but I don't know, you probably don't do triangles in elementary school, but I'm just saying we've been using this for really long, and now hopefully you understand that this is just a special case of this formula when we have a right angle triangle and sine 90 would equal 1. So this is just a special case of this formula. So let's go ahead and actually do a practice question now. If I have this triangle that looks something like this, and I have my sides A, B, and C, and I have this to be 45. Let's have this side to be 12, and this one is 13. Okay, again, I can label my sides now. So if this is A, then this side should be A. This is C, so this side would be C. And this is B, so this side would be B. How would I solve this question? So again, I need to use my formula, and that is area equals 1/2 AB sine C. Now, you might look at this diagram, look at this formula, and be a little confused. You might say, well, I know A, but I don't know what B is, and I don't know what angle C is either. What do? I have angle B, and I have side C, but, well, I don't really know what to do. Now, let me tell you that just by changing how we label this is not going to change the formula. So we're still going to use the exact same formula. But you need to understand that this is the exact same as one area equaling half of BC sine A, or equaling half of AC sine B. It's all the same formula, and in fact, it doesn't even have to be A, B, and C. It could be X, Y, and Z, or whatever you label it. So what you need to understand is that it's essentially one angle and two sides. So two sides and the angle in between is all you need to solve this formula, or to use this formula, regardless of what it is labeled as, okay? So in this case, this one actually matches the way this triangle is labeled. So let's go ahead and use this formula. If I do that, I have 1/2 times A. A is 12. C is 13. And sine of capital B, or angle B, is sine of 45. And when I just punch this into my calculator, I get 55.2, and assuming that these values are in centimeters, it's 55.2 centimeters squared. Now, if you can't use a calculator, then sine of 45, it's actually a special angle, so you'd know what sine 45 is off the top of your head, and you could do this by hand as well. Thank you, and see you in the next video.